Hello everyone, this is Tarun Kausik and today in this lecture we will be doing the part 2 of numerical methods. In the previous lecture we have studied the numerical part 1 and in this particular lecture we will be doing part 2. But before doing the part 2 portion, we will finish one topic of part 1 that we left in the first lecture. That was Runge Kutta method. Okay, so we have done Euler method. Okay, and since this is the modified Euler method and Runge Kutta method is the third order, first order, I will tell you what it is. So we have studied about the Taylor series. The Taylor series expansion we have already done. For example, if there is a function f of x plus h, then we are required to do the expansion of this function in the form of Taylor series, and then the expansion will be like this. Okay, so this h, that is increment in x, that h is the increment in x. So the power of h, let us suppose the power of h is here, the power is 1, here the power is 2, 3, 4, 5, 6 and so on. So this here h raised to power r, this define the order of the system. Okay, suppose it is 1, if r is equals to 1, then it correspond to first order. If r is equals to 2, then it is correspond to second order, and subsequently. So this modified and Runge method is not in our syllabus. In our syllabus only two methods, Euler method and Runge Kutta method, that is for the fourth order. So we will be seeing that how to solve this question irrespective of theoretical portion. You just which type of question can be asked and how to solve out these problems. Okay, so the working rule for this method is that for finding increment k of y, here k is the increment in y and h is the increment in x. So we are required to calculate the increment in y, that is k. We are required to calculate the value of k, then add the value of k into the y, so it will give the correct, or you can say approximate value of y at some particular point of x. Okay, so for example dy by dx, the derivative is given and the function f of x y comma y of x naught is given. So we are required to calculate the fourth, since the question is for the fourth order, so we are required to calculate the 4 value of k, that is k1, k2, k3, k4. And how to remember this formula? So h, that is increment, multiply increment in every form like k1, k2, k3, multiply by h in the every value of k, and in the f of x naught into y naught in the first form, and in the second you do the increment by half time of h. Okay, that is x naught plus half h. In the y, again this k1, now substitute this value over here, so half of k1. Again now you have calculated the k2, now you put the value of k2 at here, half of k2. But remember, in the k3 you are not required to do the half of this k3, you just substitute the value of k3 as it is without doing the half. And similar here in the x, write down the h as it is. So at last do the summation of all these k's by this formula, k1 plus 2k2 plus 2k3 plus k4 divided by 1 by 6, or you can say 1 by 6, multiply by 1 by 6 or divide by 6, both are same. Okay, so as you can see, this first term and the last term, add these and do the multiplication of with 2 by after adding these two, k2 plus k3 into 2, that is k2 plus k3 into 2, and add the first and last. This is the form of formula for calculating the value of k. And when you add this k into the initial value of y, then you will be getting your initial you can say final value of y, or you can say approximate value of y at some specific point of x. Okay, so this is there. So we will see this Runge Kutta method with an example. So the question is, apply Runge Kutta method fourth order to find out the approximate value of y when h is equals to 0.2, that is when the, you can say step size is 0.2, given that dy by dx equals to x plus y and y equals to 1 when x equals to 0, means initial values are 0 of x, initial value of x is 0 and initial value of y is 1. So I am taking it x equals to 0, x naught equals to 0, x y naught equals to 1, and step size h equals to 0.2. So the function, this is my function, f of x equals to x plus y. Just add these two, x plus y. So what will be the f of x naught comma y naught? Just add x naught and y naught. When you add x naught and y naught, it will become 0 plus 1, that is 1. Okay, x naught is 0, this is x naught is 0, and x1 is y naught is 1. So when you add 0 plus 1, then you get 1. Okay, so now you can calculate k1, that is x of x into f of x naught into y naught. This comes out to be 0.2. Now again, k2 can be calculated like this: h into f of x naught plus half of h comma y naught plus half of k1 here. Now how to calculate this? X naught is 0 and half of h is 0.1 because h is 0.2, so half is 0.1, so 0 plus 0.1, that is 0.1. So here I have written that is 0.1. and similar y naught plus half of k1, so k1 is 0.2, so half of k1 is 0.1, so y naught is given as 1, so 1 plus 0.1, that is 1.1. now add these two again because my function is addition of x and y. So when I add these two, I got 1.2. When I multiply 1.2 with 0.2, I got 0.24. Again put the values in the formula. Again do the same calculation. When you calculate this k4, put all these values of k into this final form, and then you get the values of k, that is 0.2428. So the value of y, we are required to, the question was to find out the approximate value of y. Okay, so the approximate value of y will be y plus some increment, and the increment is k, and the value of k is 0.2428. okay, so the final answer is this. This is an example, or you can say this is not a question which is asked in the UPSC. This question was asked in the UPSC last year in 2015 for 15 marks. The question was: solve the initial value problem dy by dx equals to x into y minus x, comma y of 2 equals to 3 in the interval 2 to 2.4. Mind it, these are square brackets. Okay, square brackets means there are two type of brackets: simple small brackets and square brackets. Square brackets means you are required to include these points. For example, 2 and 2.4, then it means you are also required to calculate the value at 2, because 2 is also included and 2.4 is also included. But if the you can say brackets are 2, 4, then you are not required to calculate at 2 and 4, because these 2 and 4 are not included, these are excluded. So the interval will be lying between 2 and 4, but except 2 and 4. Okay, this is the meaning of open brackets. And square brackets means you are required to include that point. Okay, so you are required to include these 2.2 and 2.4. So using Runge Kutta method, fourth order, you will be definitely getting the question on the fourth order. This will be 101% will be mentioned in the question paper. Fourth order method with step size equals to 0.2. So step size is 0.2. You have to start from 2, then go to 2.2, and again add 0.2, then you get 0.4, that is 2.4. So you are required to calculate the value of y at 2, at 2.2 and 2.4. So there are three values you are required to calculate at x equals to 2, at x equals to 2.2, and x equals to 2.4. That what I means in this you are required to take x naught as 2, x naught equals to 2.2, and x naught equals to 2.3 in the three different portion. Okay, so in the first portion, when x equals to 2, when you solve, assume x naught equals to 2, y naught equals to 3, because it is given. Okay, this is when x is equals to 2, then y is equals to 3, and h is equals to 0.2 as it is given, and the function is given as x into y minus x. Okay, so this is similar type of question. After this you know how to calculate the value of k1, so just put the values, get the answer. Okay, again k2, Now in this K3, similar type of, you can say that procedure is to be followed in this form, and again K4, similar type of procedure, and the value of K after calculating you will get this. So when x equals to 2, then you get the value of y that comes out to be this. Now again do the same procedure at y equals to 2.2, then you get the same, not same, the procedure is same, but the answer will be definitely different. Okay, so the answer is this, and when y equals to 2.4, you get the answer is this. So I have not used the formula again and again in this portion, but in the mains you are required to use the formula again and again. The times you are required to calculate, always put the formula for getting better marks. Okay, so this was the portion of the part 1 which we have left. So now for today's we will be doing the part 2, that is computer programming. So in the computer programming, the computer knows only one language, that is binary. Okay, so binary means 2. What 2? The base is 2. The base 2 means it has only 2 digits, 0 or 1. So the counting in the binary will be 0, 1, then again 1 is end, then 1 right and 1, again repeat this 0. Okay, so now 1 0, now repeat this 1 as it is, then write this 1 as it is. Now you are done with this, now write 10 as it is, and 10 as it is, again repeat this 0 and this 1. So this will be the counting procedure of binary system. And this R defines the base of the system. If R equals to 2, then it is the binary system. If R equals to 8, then it is octal system. If R is equals to 10, that is decimal system, which we prefer to use in the general life. And when R equals to 16, then it is hexadecimal system. So how to add these two binary system, or you can say two binary number? 0 plus 1 equals to 1, 1 plus 0 is also 1, but 1 plus 1 equals to 1 0. How? 1 plus 1, that is 1 plus 1 is 0, but 1 will be carrying. So answer is 0, not answer is 0, answer is 1 0. 1 is to be considered as carry. Now the subtraction is 1 minus 1 is 0, 1 minus 0 is 1, but 0 minus 1, so we will take 1 carry from this point. Okay, so it will become 10. 10 minus 1 is 1, so here there will be a 0. Okay, so we will borrow 1 again, so it will become again the same. 1 minus 1 1. Okay, that will be 10. 10 minus 1 1. So this answer is in the form of complement. Complement means if there is 1, the complement of 1 is 0, and 0, the complement of 0 is 1. Complement of 0 is 1. Okay, so this is the complement. So when you do the complement of this, you will get your actual answer. Okay, so this is the addition, and the multiplication is very simple. 1 1 0 1, 1 0 1 1. When you multiply this with 1, you will write the same. Again with 1, write the same. When 0, write down all of the value as 0. When again do the multiplication with 1, write down the value as it is. When you add these, you will get your answer. Okay, so octal system already mentioned. The base is 8, means the counting will be starting from 0 and it will went up to 7. Okay, so arithmetic operation means octal. Which type of arithmetic operation? A word is mentioned in our syllabus, that arithmetic operation and logical operation. Arithmetic operation means addition, subtraction in different you can say number system, like binary system of hexadecimal, decimal, octal. So in octal, how to add? Okay, means addition. How to do the addition in the octal system? So 1 plus 1 equals to 2, 1 plus 6 equals to 7, but we are having the counting up to 7. We don't have the counting after 7. So what we will do? 7 plus 8 is 7 plus 8. 1 plus 7 is equals to 8. So 8 we will write down as 0, and we will put 1 as a carry. Okay, so इसकी छोटी सी hint ये है, whenever you are adding these two octal number, the number which you are getting after 7, or you can say 8, just subtract that value from it. What I mean is that in Hindi I am explaining now for Hindi speaking. 7 6 5 4 2 7 4 2. If we are adding these two, then how to add? 4 2 6. Okay, 5 और 4 9. 5 और 4 9. जो ये 9 है, ये 8 से कितना ज़्यादा है? एक ज़्यादा है, तो आई राइट डाउन 1. ओके, मैंने 1 लिख दिया. अब और एक कैरी चढ़ा दिया. 7 और 6 13 और एक 14. 14 is how much ahead of 8? It is 6 time, or you can say not 6 time, it is 6 more than 8. So I write down 6 again. Okay, now 6 carry 1. 7 2 9 plus 1 10. So 10 is how much ahead of 8? That is 2 time, or no, not 2 time, it's not 2 value, 2 time, or you can say 2 value. So I wrote 2 again. 1 carry, I wrote 1. Okay, so subtraction is very simple. In decimal, we all are familiar with the base system, that this base system, that is 10, we always prefer to do, or in general life we always do the multiplication, subtraction, addition in the decimal only, because we are having the counting from 0 to 9, and after 9 what we write? 1 0 and 1 1 1. Okay, so there is no need of learning from the decimal, you all are perfect in this. Hexadecimal, the base is 16, means the counting will be starting from 0 and it will went up to 15, but after 9 there will be not 10 11 12 13, it will be in the alphabetic form, that is A B C D E F. A correspond to 10, B correspond to 11, and subsequently F correspond to 15. So how to add these? Again the same procedure, कि जैसे ऑक्टल सिस्टम के अंदर 7 के बाद जैसे 8 आया था, 8 जो भी नंबर था उस नंबर में से 8 घटा लो, जो भी नंबर बच गया राइट डाउन दैट नंबर. फॉर एग्जांपल एफ कॉरस्पॉन्ड टू 15 एंड 4 कॉरस्पॉन्ड टू 4, 15 और 4 19, दैट इज 19. 16 से कितना ज़्यादा, ये 3 ज़्यादा है, तो आई राइट डाउन इज 3. अगेन दिस बी दैट कॉरस्पॉन्ड टू 11 and write down, don't forget to put a sign of 1 because 1 is to carry, 1 is the carry. B is 11 plus 4 15 plus 1 16, so 16 minus 16, that is 0, so I write down 0. So do the same procedure, you will get your answer. Okay, so this is about the arithmetic operation. Now logical operation, that is first we will study the logic gates that will correspond to the logic operations which we will be following. So first AND gate. AND gate means we are doing the multiplication of the two inputs. Okay, so gate is used in the you can say that digital electronics for getting output as high or low. Okay, so in AND gate the input is multiplied, that is if the both our inputs are 0 then we are getting nothing. If one of the input is 0, still we are not getting any output, because 1 into 0 or 0 into something, that answer is 0. So 0 dot something, that answer will correspond to 0. So you will not get any answer up to the 3, you can say 3 iteration. In the fourth, when we put both the input high, that is 1 1. 1 means here 1, what do you mean by 1 and 0? 0 means low and 1 means high output. Okay, there is no output, that corresponds to 0, and when there is input, or you can say output, then it corresponds to 1. So this is the logic gate symbol, this is the Boolean algebra, or you can say Boolean expression for AND gate, and this is the TT means truth table. So it is NAND, N for NAND, not N for NAND. Just when you put the N for NOT, if you put a NOT in front of AND gate, that is the symbol of NOT, that is the bubble, which bubble you have inserted ahead of this AND gate. If you insert this, then it will become NAND gate. And OR gate, you are doing the addition, A plus B. If you are getting a single 1, then your answer will be definitely high. Okay, NOR, put the bar over here, this is a symbol, truth table, you can see. NOT gate, inversion of the input, whatever input you will be giving, the output will be revert of that. XOR and XNOR, these two type of gates are very much used in the digital electronics for doing various arithmetic, or you can say various operations like comparing, adder, subtractor, or you can say parity bit generator. Various types of applications are there of this, you can say XOR and XNOR gate. This is the symbol of XOR and this symbol of XNOR. This is the Boolean expression of this and this. So this is the truth table. So how to remember XOR and how to remember XNOR? So if you are getting odd number of 1 in the truth table, or you can say input side, then the output will be high. Okay, odd O for odd, O for 1, or O for odd, O for 1, and last में आंसर भी 1. यदि odd number of 1 है तो 1 आएगा. Okay, यदि इसके अंदर ओड नंबर ऑफ 1 है तो ओ मीन्स 0 आएगा एक्सनोर के अंदर। ओके, क्योंकि यहाँ पे तो दोनों दो इनपुट थी। फॉर एग्जांपल देयर आर मल्टीपल इनपुट्स, फॉर एग्जांपल 1 0 1 1 0 1 0 and 1. How many inputs are there? 1 2 3 4 5 6 7 8. There are 8 inputs. So what will be the output if I am using XOR gate? How many number of ones are there? 1 2 3 4 and 5. 5 is a odd. When I have told, when the number of ones are odd, then the answer will be 1 or any 1. Okay, so answer will be high, output will be there will be definitely output, and output will be 1. Okay, so in XNOR that procedure will be approximately, you can say that, not approximately, definitely reverse of this. So SOP and POs, these are not in the syllabus, but I want you to tell about SOP, that is the sum of product, and POC means product of sum. As you can see over here, this is A into B bar plus A bar B. This is the product. Okay, A bar B and A B bar, these two are the products, and I am doing the sum. So it is the sum of what? It is the sum of the product. So this is the SOP form, and this is the sum, and this is the sum. So this is the product. Okay, so this is the product of the sum. So I have implemented this. These two are AND gates, so I have used AND gates in this, and after doing that, the summation, so I used a OR gate over here. Okay, so in this first I use OR gate because it is the sum after product. So for product I used AND gate. Okay, so in 2014 a question was asked, use only and OR gate or logic gates to construct for Boolean expression. This the Boolean expression was given, so we will be using the two AND gate over here, and for generating this as a output, and one output will be of these two inputs AND gate, and after doing getting the output, just put a OR gate ahead for getting the output Z. Okay, so this is the simple question asked in the 2014 mains. So logic gates के बारे में अभी तक हमने पढ़ चुके हैं 7 logic gate, NOT, NAND, OR, NAND, NOR, XOR, XNOR. So these first three, NOT, and OR, these are called basic logic gates. This NAND, not A, this is D. NAND and NOR, these are called universal because we can construct any kind of logic gates by using these two gates, NAND and NOR. Okay, and XNOR and XNOR, we have already talked about this. For arithmetic device construction like comparator, adder, mux means multiplier, multiplexer, demultiplexer, parity generator. So such type of various, you can say, high type of applications of these logic gates, XOR and XNOR. Okay, so the next point is De Morgan's theorem. This is a very important theorem because many questions can be asked by, since no question has been asked, but it can be asked anytime because it is very important. Why? You just see A plus B bar, that is equals to, how to what is the process? So you are required to remove this bar from the complete. When you put this bar over A and this bar on the B, then you will require to change the sign plus from sign plus into dot sign. Okay, plus sign into dot sign if you are changing the bar position. So here if you are changing the bar position from this to this, then it will become A bar, B bar, then dot will be changed into plus. Okay, it's very simple, De Morgan's theorem, and it is very helpful in minimizing any Boolean expression. Okay, so now the very important question or topic comes. The topic is conversion of the system in one another. For example, if any binary system is given, binary number is given, and we are required to convert into the various other forms like octal, decimal, hexadecimal, and so on. Okay, so first we will doing binary into octal. So this is the binary number, and we are required to how much this is equal to the in the octal system. So octal means 8. 8 means 2 raised to power 3. So the base is 8, but how many pairs it will be forming? It will be forming 3. Means there will be 3 address line for this octal number to represent. So we will do the, what we will do? We will do the grouping of three words, three you can say that binary number. So these three last three correspond to 7. Why? How it is 7? So first digit is 1, next digit is 2, and next is 4, next is 8. So how I'm going in the form of 2 raised to power 0, that is 2 raised to power 0, 2 raised to the power 1, 2 raised to the power 2, and 2 raised to the power 3, and so on. Okay, so we will be moving in this direction, 2 raised to power 4, 5, 6 and up to 2 raised to power n. So we are moving in this direction. So if this is 1, this is 1, this is 1, 4 into 4, that is 4, 2 into 1, that is 2, 1 into 1, that is 1. So 4 plus 2 plus 6, that comes out to be 7. So that's why I have written it here, that is 7, it corresponds to 6, it corresponds to 6, and it corresponds to 1. So the answer in the octal form is 1667. Okay, so I have explained this B to D in this point only. Okay, so how I have written this. So for example, 1101 in the binary, then what is the equivalent of this in the decimal form? So write down 2 raised to power 0, 1, 2, 3 in this form, and write down, I can explain this. When I expand this, 2 raised to power 3 equals to 8, 2 raised to power 2 equals to 4, 2 raised to power 1 equals to 2, 2 raised to power 0 equals to 1. Just do the multiplication. What I get? 1 into 1, 1, 2 into 0, 0, 4 into 4, 1, 8 into 1, that is 8, 8 plus 4, 12 plus 1, 13. So it comes out to be 13. Okay, so B to H, similar again. Now we are doing the hexadecimal, means 16, 16 is 2 raised to power 4. So we are required to do the pairing of 4 binary words. Do the pairing, get your answer. Okay, so decimal to binary, in this binary that is 25, how much in 25 in decimal equivalent to binary? So in this form you are required to do the you can say that division by the number in which system you are going, by the base of that system in which you are going. For example, if you are moving from D to octal, then divided by 8. If you are moving from D to binary, then divided by 2. If you are moving from D, then moving towards the hexadecimal portion, then divided by 16. This is the process which we have done in this form. Okay, so B2, oh, what we have done, divided by 8. So how to do? So 2, 12, 25, that remainder 1, 2, 6, 12, remainder 0, 2, 3, 6, remainder 0, 2, 1, 2, that remainder is 1, and 1 is still remainder. So write in this form, from the this portion to this portion, write in this form. So what you get is 11001 in the form of in binary form. Then D to O, that is decimal to octal. So in 108 in decimal, then how it is, how much is equal to 108 in octal form? So octal form means 8. So divide this by 8, write down the remainder here, and write again in the reversible, in the reverse direction, 154. That will be the octal number of 108 in the octal form. Now D to H means decimal to hexadecimal. So this 2754 in decimal, then how much it is equal in the hexadecimal form? So divide this number by 16, you will get your answer. So write down the number in the reverse direction, so you will get your answer. So now hexadecimal to binary, octal and decimal. So we will be seeing first hexadecimal to binary. So AB03, this is on 16. So we are required to write down in the binary form. Expand A in the binary form, we have already done. A correspond to 1010, A is 10. Then how to write down 10? 8 0 1 0. This is 8 and this is 2. 8 plus 2 is equal to 10. So this is the right form of writing the 10 in the binary form, 1010. So I have written over here 1010, and B, that is 11, written over here. 0, write down in the 4 0. Why? Because it is in the hexadecimal. 4 0 आएंगी क्योंकि ये hexadecimal है. 4 बेस होता है, 4 ग्रुपिंग, 4 नंबर ग्रुप करना पड़ता है इसके अंदर। ओके, तीन के लिए अगेन 0011। ओके, H2O हेक्साडेसिमल टू ऑक्टल, अगेन 2EF जो भी नंबर दिया हुआ होता है उसी को पहले हम बाइनरी में जाएंगे बाय डूइंग द सेम प्रोसीजर। उसके बाद बाइनरी में जाने के बाद तीन की ग्रुपिंग, डू द ग्रुपिंग ऑफ 3, अगेन गेट योर आंसर। हेक्साडेसिमल टू डेसिमल, तो डेसिमल में जाने के लिए क्या करेंगे, उसी के पावर से 0, 16 की पावर 1, 16 की पावर 2, उसको एक्सपेंड करेंगे 16 की पावर 0 दैट इज़ 1, 16 रेज टू पावर 1 दैट इज़ 16, 16 रेज टू पावर 2 दैट इज़ 256। Do the multiplication, get your answer 2756. I have done it to show that we have done it previously. We have expand from, you can say, convert from decimal to hexadecimal. Now we have converted it from hexadecimal to decimal. Now fourth, octal to binary and decimal, this is the same procedure. You will get to know, because you are a very intelligent person and you will definitely do this by seeing the previous conversion. Okay, so we have done this. Now the flow charts. So this question can be asked, and it was asked in 2014, right? We are required to expand the flow chart, so you can just went through it. If you can understand, then it will be very good for you. Otherwise I will not explain this flow chart. Okay, so you have to cram it somehow. So I have compiled it from various sources to at one place so that you can go through once. So this is the bisection, regula, falsi method, Newton-Raphson, Gauss elimination, Gauss-Jordan, Gauss-Seidel method, trapezoidal. We have done these rules, but we have not done this. We are not doing this flow chart method of this. So 1/3 rule, this was asked in the UPSC 2014. Okay, you will do it by yourself, you will cram it. Okay, you have to cram it, there is no shortcut, you have to cram it. Okay, I have compiled it from the various sources, so it's up to you, you have to cram it. Okay, so in this numerical method only one thing was remaining, that is memory. So in memory you can go through the internet, on Wikipedia you can read about the memory, the type of memory, the computer. And this is a very simple computer knowledge is where the component of computer like arithmetic, logic unit, okay, registers that are used for computer component, that is ALU, arithmetic logic unit, ALU, that is not C, that is U, ALU, registers. Okay, R for registers, for storing the memory, or you can say data structure. If you have read the data structure, then there will be 4 type of data structures, you can go through them. Main portion was memory. So memory, there are 2 type of memory, random access memory, that is RAM, and ROM. So RAM is 2 type, static RAM and dynamic RAM. And ROM, there are many type of ROM, EEPROM, okay, electronic erasable, and various type of ROM are there. Okay, you can go through them. So it is not of teaching, it's just of cramming. So you can go through them at your own through internet or various sources available to you. Okay, so numerical methods we have done. So in the next lecture we will be doing calculus. Okay, because I am currently you can say that focusing on different portion. First I think that I should cover partial differentiation. Sometime I thought that first I do partial, or you can say ordinary differential equation, but if I do the calculus, then the partial differentiation and the ordinary differential equation, that will become much more simpler. So in the next lecture, very soon, that will be very soon, will be uploaded. In that we will be doing the calculus complete. Okay, so in numerical method, that is all from my side. So thank you for watching, and you can download these PPT of the lectures at the link given in the description below. Okay, so that's all for this. If you like this video, please click on the like button, and please do share these videos as much as you can possible. Okay, and please do not forget to subscribe to my channel for getting the information directly into your email account about the uploading of the lectures. Okay, so alright, all the best, and thank you very much for watching this video.